Hi, this is AJ sir. Let's study 10th standard ICSE physics chapter 12A sums based on number of alpha and beta particles in radioactivity. Physics sums 12A. Solved example number 11. We start with a uranium nucleus with atomic mass 238 and atomic number 92. It undergoes several disintegrations, which could be alpha or beta particles released, and ultimately it forms lead with atomic mass 206 and atomic number 82. How many alpha and beta particles are emitted? Now first we should always look at the atomic mass number or atomic weight. 238 reduces to 206. We know that whenever an alpha particle is released, the atomic mass reduces by 4 and the atomic number reduces by 2 for each alpha particle released. After all, an alpha particle is nothing but a helium nucleus. So we can calculate the number of alpha particles with this formula. The original atomic mass minus the new atomic mass divided by 4. So that means totally 8 alpha particles were released. Because if 8 alpha particles are released, only then will the atomic weight decrease by 32, which is what has happened. But that would mean that the atomic number should also decrease. For one alpha particle, the atomic number decreases by 2. So for 8 alpha particles, the atomic number should decrease by 16. But we see that the atomic number has decreased only by 10. That means some beta particles were also released. Whenever a beta particle is released, the atomic mass doesn't change at all, but the atomic number increases by 1. Because a beta particle is released from the nucleus when a neutron changes to a proton. That doesn't change the number of nucleons in the nucleus, but it does increase the atomic number by 1. So the expected decrease because of alpha particles was 16, but actual decrease is only 10. That means 6 is the increase in atomic number due to beta particles. So 6 beta particles were released. If you don't wish to use logic and use a direct formula, then go for this one, which says the final atomic number minus the initial atomic number plus 2 into number of alpha particles. So that's 82 minus 92, that's minus 10, plus 16, that comes out to be 6. So that's a direct formula for calculating number of beta particles, and this one is for number of alpha particles. Next, the exercise question 35. A nucleus, AC, emits 2 alpha particles and 1 beta particle, and the final atomic mass is 222 and the final atomic number is 85. So what is the original atomic number and atomic mass number? So in a sense, this is the reverse of the previous sum that we did. You can use logic again. For example, the mass number is 222 and 2 alpha particles were released. That means the total decrease in atomic mass would be of 8. So the original atomic mass should be 230. Now I can also use the formula to solve this if you don't want to use logic. The formula said that the number of alpha particles is A1 minus A2 upon 4. The number of alpha particles is given as 2. A1 we don't know, so we take it as A, which is the variable used here. And A2 is 222 upon 4. Cross multiply, get the answer of the original atomic mass number as 230. Now, number of beta particles formula is Z2 minus Z1 plus 2 alpha. Number of beta particles is also mentioned in the question as 1. The final atomic number is given as 85, but the original atomic number is not given, so we take it as Z. And we know the number of alpha particles. So substitute the values and solve, and we get the value of new atomic number as 88. Now let's solve question 37. P turns into Q with the evolution of a beta particle from the atom. Now whenever a beta particle is released, the atomic mass remains the same as A, but the atomic number will increase by 1, so it will be X plus 1. Bravo. Uranium becomes thorium. energy is released, but what else will be released? What particle will be released? Alpha, beta, and how many of them? Well, the mass number changes by 4, decreases by 4, and atomic number decreases by 2. So obviously it will be an alpha particle. So either write an alpha particle symbol or just write an helium nucleus symbol. So just write the answers like these. Next, Charlie. We see a step-by-step radioactive decay, alpha, beta, and again beta. When alpha is released, the atomic mass will become 234 and atomic number will become 90. When beta is released, the atomic mass remains the same, but the atomic number will increase by 1, so it will become 91, and so on. Notice how S and P are actually isotopes, because the atomic number is same, 92 and 92, but the mass numbers are different, 238 and 234, because of different number of neutrons. On the other hand, if the atomic mass numbers were same and the atomic numbers are different, they are called isobars. Can you identify any isobars in this Charlie question? Yes, Q and R are isobars because 234 same atomic mass but 1991 different atomic numbers. Next question is the delta one. So alpha is released, gamma is released, and 2 beta particles are released. So let's understand step by step what will be the atomic mass numbers and the atomic numbers. Whenever alpha is released, the atomic mass decreases by 4 and the atomic number decreases by 2. When gamma is released, there is no change in atomic mass number or atomic number because gamma is pure energy. No particle is being released here. Yes, the total nuclear energy in X2 will be a little less than the total nuclear energy of X1, but the element is still the same. So often after an alpha or beta particle is released, gamma is also accompanying them. And finally, when 2 beta particles are released, again atomic mass never changes, but atomic number does increase by 1 per beta particle. So here 2 beta particles, so it will increase by 2, so it will become Z again. Notice how X here and X3 here, both are again isotopes because atomic number is same. And finally the echo question, which is challenging because now we have to think in a reverse order. Here the final atomic mass and atomic numbers are given and we have to keep finding the ones of the previous elements. So let's start from X3. If an alpha particle is released, that means X2 will have atomic mass 4 greater than 172 and atomic number 2 greater than 69. Hence, it's 176 and 71. Similarly, again, an alpha particle is released, that means the previous atomic mass will be 4 more than 176 and the previous atomic number will be 2 more than 71, so that's 180 and 73. And finally, if a beta particle was released here, that means the atomic mass of the very first element would have been the same as 180, but the atomic number would have been 1 less. That's right. See, whenever beta particle is released, the atomic number is supposed to increase by 1. So if you go in the reverse order, it will increase by 1. So it will decrease by 1. So it's 72.